HPC, this is Trig Notes number 6, functions of any angle. So today we're going to be using those same special angles that we talked about last time. Those were the 45s, the 30s, and the 60s. And you can see that they are in these special triangles that we talked about before. So if you remember, the reason that I said that 45 triangles were really super important is because if you put two of them together, you get one of our basic polygons, which is a perfect square. Right? And then if you put one of these together, a 30, 60, 90, and you attach it to the 30-degree side, and I'm just going to outline this really, really lightly here, we end up with a perfect equilateral triangle. So perfect four-sided figure, perfect three-sided figure uses all of those interior angles. So what we want to do is we want to go back and make sure that we can put these in order and put the sides in order of what would show up on a unit circle. So in a unit circle, remember that our biggest thing here is that our hypotenuse is a 1. So that's what we're trying to get to. So looking at this one, looking at the 45-45, if the hypotenuse is a 1, well, we know that side A and B have to be the same amount. So I'm going to call them side A and A. And if I put them into Pythagorean theorem, I'm going to get a squared plus a squared equals 1 squared. That's going to be 2a squareds equals 1. That's going to be a squared equals 1/2, and that's going to be a equals the square root of 1 over 2. And that's going to be 1 over square root of 2, and if I go to fix it, it's going to turn into square root of 2 over 2. That kind of makes sense? So this side is also square root of 2 over 2. In a 30, 60, 90 triangle, again, we'd want the hypotenuse to be 1. But remember that extra little equilateral triangle that I showed in there? Well, that also means that this side is a 1, and that also means that this side all the way to here is a 1. And if that's a 1, then that means that this side is just 1/2. And then to find the missing side, I'm going to call it b. We can use Pythagorean theorem for that. So I'm going to have 1/2 squared plus b squared equals 1 squared. So 1 over here, b squared over here, and this would be 1 times 1 on top, 2 times 2 on the bottom would be 1/4. So b squared would be equal to 1 minus 1/4, or 3/4. And if I take the square root of those, I'm going to get square root of 3/4, which is going to be square root of 3 over 2. So this side is square root of 3 over 2. Cool? All right, so what does that mean? Well, it means that when I go to take sine, once I've moved it onto the unit circle type, then I can just pretend that this is the y value, right? And that where is our central angle going to be? Our central angle for each one of these are going to be attached to the horizontal. So that's going to be down here for each one of these, right? Okay, all right. So the power of this now is if I can see it as how it would possibly be on a unit circle, I can just go ahead and use sine is the y, cosine is the x, and tangent is the y over x. Or I can go ahead and use SOHCAHTOA and do s is o over h, and c is a over h, and t is o over a. And I can use these interchangeably as long as the radius is 1, and I can imagine it on a unit circle. So for the sine of 45, use SOHCAHTOA, it would be opposite over hypotenuse. So opposite would be square root of 2 over 2, and hypotenuse would be 1. So it'd just be square root of 2 over 2. And if I went and I did cosine of that one, it would be square root of 2 over 2 over 1, also known as square root of 2 over 2. And if I did tangent, it would be square root of 2 over itself, which would just be 1. So you can see that I end up using the exact same amounts because the hypotenuse is of 1. It ends up just being each one of those. All right, for the second one, remember that we said on the unit circle they always had to be attached to the horizontal. So 30 I could use either way, but 60 I'm probably going to have to go back and do SOHCAHTOA for, only because it's not one of my horizontal ones, so it's harder to see. So let's change the colors of this one, and let's do 30 degrees first. So if I'm at 30 degrees, O would be 1/2. And h would be a 1, that's just a 1/2. So you can see how this kind of just turns into the 1/2. Cosine is just going to be square root of 3 over 2 over 1. And tangent is going to be O over A, so 1/2 over square root of 3 over 2. is the same thing as 1/2 times the reciprocal, which is going to be 1 over square root of 3. And then if I fix that, it's going to become square root of 3 over 3, right? Because I multiplied top and bottom by square root of 3. All right, but if I go to do sine, sine is going to be a little bit trickier. I'm going to have to use SOHCAHTOA on that one. So if I'm standing up here instead, then opposite is now square root of 3 over 2, but hypotenuse is still 1. So square root of 3 over 2. Cosine would be adjacent over 1. And now tangent would be over A, which would be square root of 3 over 2 over 1/2. And now when I turn that into a multiply problem, multiplying by the reciprocal, it just becomes square root of 3. Cool. So we'll start seeing those same references over and over and over again. So converting those, remember that 45 degrees turns out to be pi over 4, and 30 degrees turns out to be pi over 6, and 60 degrees turns out to be pi over 3. Now, how did I do that? Remember, every single one I just multiply by 180 degrees on the bottom, pi on the top, reduce, and that should give you your answer for each one of those. All right, so since all those same sides are going to keep showing up over and over again, square root of 2 over 2, 1's for radius, 1/2's, and square root of 3's over 2. So we're going to see a lot of those. One of the easy ways to remember this is not only using that idea of all students take calculus, but also just creating a chart. And so in the chart, we want these angles to go up by, put those in order as they go up. So increasing. So of these three, the lowest one is this one. So I'm going to start out with pi over 6. So that's going to be 30 degrees or pi over 6. Okay, and then the next one that I'm going to do is going to be the 45. So the 45 is going to be 45 or pi over 4. And then the last one we're going to do is going to be the 60. So 60 degrees or pi over 3. Okay, so those are now in increasing order. So here's the kind of cool thing is if we go back and we look at this, the sine of a 30 degree. So for right now, I'm just going to go look at them and go grab them off of the stuff we just did before. Sine of 30 degrees was 1/2. Okay, if I go and look at sine of 45 degrees, it was square root of 2 over 2. And if I go and look at the 60 sine for that one is square root of 3 over 2. So what I want you to notice about that is, do you see the pattern across the top? They're all 2's on the bottom, but the first one is 1 out of 2, square root of 2 out of 2, square root of 3 out of 2. You could almost even argue they're all square roots at the top, it's just that the first one simplifies. That's a really easy way to remember them. So then for the next one, we just reverse the order. It becomes square root of 3 over 2, square root of 2 over 2, square root of 1 over 2. And then again, tangents just become that you're going to imagine that we are dividing these to get to tangent. Okay, so if they have the same denominator, they're just going to turn into the numerators over each other. So this is going to turn into 1/2 times 2 over square root of 3, right? And then we simplified that. So I want to erase this so that the only thing that is filled in here is our answer, which is 1 over square root of 3. So let me go and erase. Ta-da! So 1 over square root of 3, and if we fix that, it's going to be square root of 3 over 3. And you can see again that this over this becomes here. Okay, and the 2's just end up canceling out. So on to the next one, right? If I have something over itself, that's going to reduce to 1. And in the third one, I'm going to have it go in reverse order. It's going to be square root of 3 over 1, which is going to just be square root of 3. So So you can see how easy this is now to go back through and find out that anything that is a 30-degree angle, and you can just create the chart and always have it with you. All right. The other thing that we want to do is, well, these weren't all the degrees, right? There were some other ones. There was 0 degrees. There was 90 degrees. What about those? Okay, so taking a look at those. For those, they're not going to work as nicely here. And here's why, is we're going to go back to the unit circle, and I'm going to go put dots on 0 and 90. And I'm going to say that if this circle is a unit circle, then every radius is 1. Right? So this distance is just a 1. So this coordinate point would be 1, 0. And if this coordinate point is 1, 0, then cosine of 0 degrees is just a 1, and sine would be 0. So it's no shocker that if I go backwards, this is 0 over 2. And this becomes what? What do we do for the cosine? Cosine, we want it to be a 1. Right? So it doesn't really work that well unless you call it square root of 4 over 2, and then that's 2 over 2, which is 1. That's kind of cool, right? And then for tangent of this one, I could actually do that, right? 0 on top is okay. So 0 over 2 would be the tangent for that point. So we can just use cosine and sine based on where they're located on the unit circle. Right? So here is our unit circle going around like this. Right, kind of like that. Okay, then this part right here would be 0, 1. It also has a radius of 1. Right, now this one is the cosine, this one is the sine of 90 degrees. So cosine at 90 degrees is 0. Look at it go downhill, 4, 3, 2, 1, 0. And then if I wanted to do the sine here, look at it go uphill, square root of 1, square root of 2, square root of 3, square root of 4 over 2, which is also just known as 1. And this one would be undefined, right? Because I can't put 1 over 0. You can't take one slice of a nothing pizza. So on these vertical and horizontal spots, you can either just use that x's are considered the cosines and y's are considered the sines, or you can add them to the table if you want on the outside edges and just follow along like that. So this one becomes a negative 1, 0. So again, cosine would be just a negative 1. Sine would be a 0 still. So we'd still be under this one. And then for over here, we would have a 0, negative 1. So again, cosine at, let's see, this is 180, this is 270. So cosine is going to be 0. Notice that the cosines for these two are the same. The sines are a positive and a negative. Let me move that up so you can see it. And then this is sine for this one. Cool, so they fit into the table too if you want, but most people just look at where they are if they're vertical or horizontal and just use their single unit x or y as their answer. And then to do tangent, they just do sine over cosine. And just imagine those two dots turned over each other. Awesome, all right. So also looking at our reciprocal functions, remember that cosecant is just sine flipped over, right? The reciprocal. And secant is just cosine flipped over, and cotangent is just tangent flipped over. So we still have our reciprocal functions. So let's go and find all 6 trig values now using this knowledge that we know about the table. So if we have pi over 3, the first thing I want to do is I just want to draw in the reference triangle. So in a pi over 3, I know that that is going to be right about here for 30 degrees, right? And then I'm going to use my knowledge either of the table that I'm thinking of, right? That it went pi over 6, pi over 4, pi over 3, right? And I'm just going to use all the ones for this one. So if you remember, sines went uphill, so this would be square root of 3 over 2. Cosines went, so sine was that one, cosine should be at the other side, so this should just be 1/2, and tangent should be those two over each other, which should just be a square root of 3. Then don't forget to go back and do, all students take calculus and get the signs right. So in first quadrant, absolutely everything is positive. That's the originals, that's the reciprocals. Okay, and then the last thing I do is flip these over. So this is going to be 2 over square root of 3. When I fix the radicals, you're going to get 2 square root of 3 over 3. This one is just going to be a 2. And this one is going to be 1 over square root of 3. And when I multiply those by square root of 3, we're going to get square root of 3 over 3. Okay, all right, taking a look at the next one. On the next one, we have 225. So the first thing is to figure out where we would draw that one. So 225, 0, 180. How far is it from 180? It is 45 away from 180. So that's going to make a 45-degree reference triangle in quadrant 3. And in quadrant 3, we have T is the only thing positive. All students take calculus. Then I can go back to my table and remember that this is the sine version, right? So we're looking at sine for 45. So I'm kind of thinking what this one is, it's always the middle thing. So it's square root of 2 over 2. It's square root of 2 over 2. And then when I put them together, I'm just going to get a 1. Let's put in the correct signs for that. If tangent is the only thing that's positive, then these two are negative. Then these two are negative, and these are positive. Okay, and then we're just going to flip them over. So if I flip these over, we're going to have 2 over square root of 2, and when I fix it, I'm going to get 2 square root of 2 over 2, and the 2's are going to cancel, and I'm just going to get negative square root of 2. Okay, and this one, when I flip it over, is going to be the same thing, negative square root of 2, and if I flip a 1 over, I'm still going to get a 1. All right, so now we had 2 different places, put them into 2 different quadrants, and I'm still going back to that table and thinking about what's that pattern. Okay. All right, so on to the next one, 11 pi over 6. So 11 pi over 6, this is 0 out of 6, this is 6 out of 6, this is 12 out of 6. So it was on its way here. So that means this is a pi over 6, right, for the reference angle. And we're in quadrant 4, which is all students take calculus, which is C is the only thing that's positive. So I already know this is going to be positive, and the rest are all going to be negative. Okay, then I'm going to go back to wherever it has my pi over 6 stuff. Let's go back to the table and take a look. My pi over 6 stuff is the first column down. So on the first column down, if we're going to do sine, I'm going to say sine is 1/2. So let's go find that one. So we said sine was 1/2. And then the next one after that was square root of 3 over 2 underneath that one, right? And then the next one after that was 1 over square root of 3. Okay, so again, all I'm doing is I'm going back and looking at the table, and I'm just pulling each one of those numbers from that column all the way down because they all represent pi over 6. All right, we've already got our pluses and minuses. So then the next thing is just flipping them all. So this is going to be a 2. This is going to be a 2 square root of 3. This is going to be a square root of 3. And again, wherever it needs to, you're going to fix your radical values. And this is just going to become negative radical 3 over 3. And this one is going to become positive 2 square root of 3 over 3. All right, let's try one more. Let's do 330. So in 330, looking at that, we've got 0, 180, 360. We're definitely close to 360. We're 30 degrees away. So that makes this a 30-degree reference angle, 30-degree reference triangle. This is quadrant 4, so all students take calculus. Calculus is the only thing, so cosine is the only thing that's positive. That means all the rest are negative. And we're going to go look for what's happening with a 30-degree. So back to our table, in a 30-degree, it's 1/2 radical 3 over 2 radical, right? Moving on, doing the same thing here. So on this one, it's going to be a 1/2. Isn't it going to be the same thing as radical pi over 6, right? So 1/2, and then we're going to have radical 3 over 2, and then 1 over square root of 3. Flip these all over. We're going to get that, and this is going to be this lovely thing. Okay, and I'm going to stop simplifying these for a little while. You get the idea for those. All right, now they're going to throw a curveball at us. Now they're going to throw us something that we cannot draw a reference triangle because it is right on a vertical or a horizontal. Where is pi? Pi is right here. So we're just going to go to what is its point location. It would be at -1, 0. So this is our cosine answer. This is our sine answer. So sine is 0. Cosine is -1. Imagine you put 0 over -1. If it's possible with a 0 on top, you write a 0. If there's a 0 on the bottom, you write not possible, or our word is undefined. So when I flip this one over, what does that look like when I move over to here and I flip it over? Well, we're going to pretend it's 0 over 1 or 0 over anything. And when you flip it upside down, it becomes undefined. Okay, if I take -1 and flip it over, it's still -1. And if I take this one, 0 over -1 and flip it over, -1 over 0 is going to be undefined again. Yay. All right. 270. So 270 is going to be, here's 0, here's 180, here's 360. Isn't 270 halfway in between, right? So if I take, oh, it's 90 after, it's exactly here. 270 is right here. Well, we're just going to turn it into its coordinate point, which would be 0 for x's. Don't go left or right at all, just go down 1. And again, the first one is our cosine, and the second one is our sine. And when we imagine -1 over 0, that is definitely undefined. When I flip it over, though, 0 over -1 is just going to be a 0. -1 flipped over is a -1. And secant would be like a number like 0 over 1 or 0 over -1 flipped over would be like a 1 over 0 or an undefined. Cool. Alrighty. -5 pi over 4. Let's go take a look at this one. All right, so -5 pi over 4. We're going this way. So this would be 0 over 4, 4 over 4, 8 over 4. So we definitely made it past 4 over 4, but we only made it 1/4 of the way. So that's going to create a 45 right here, or sorry, a pi over 4 right there. So pi over 4 is our reference angle, and it's in quadrant 2. So that's going to be sine is the only thing that's positive. Okay, and then we're going to go look for pi over 4 in our table. So pi over 4 in our table is that middle one. So we're going to start out with sine being square root of 2 over 2 and tangents being the 1. So square root of 2 over 2, square root of 2 over 2, tangent is the 1. Flip these over, and these are just going to turn into 2 over square root of 2, 2 over square root of 2, and flip over a -1, you still get a -1. And again, we could fix those radicals in the denominators. All right, 120, negative. So 120, if I'm going this way for negative, this would be -180. We didn't make it that far. So we are 60 degrees before we hit 180. That's about here. So we are 60 degrees before. That's our reference angle. So this is a quadrant 3. All students take. Tangent is the only thing positive. Okay, so now I can go back up at my table, look at 60s, and start writing them down. So 60 degrees in my tables, that was the last one. So radical 3 over 2 and then 1/2. So radical 3 over 2 and then 1/2. And then if I imagine those stacked on top of each other, we would get that. Flipping them over would be 2 over radical 3. I'm getting tired of fixing those, so I'm going to leave those for now. 2, and then this one would be, if I flip it, would be 1 over square root of 3. Cool. So that's one of our ways we can visualize all of these and just go and draw, get our reference angle that creates our reference triangle in a quadrant. We use our quadrants to figure out what's positive and negative, and then we just start filling it in directly from that form. All right, that's it. See you next time.